From self-pouring liquids to literally invincible alloys, come with me as we take a look at some recently discovered materials that take innovation to the next level. Self-pouring polymer. To empty a cup of liquid, you usually have to tip it out all the way. Except there's one liquid out there that hardly has to tip at all, because it pours itself. This bizarre material is a self-pouring resin polymer. Now, polymers are materials made up of a repeating chain of molecules called monomers. These monomers are combined in a chemical reaction called polymerization, forming chain structures called polymers that make for tough, durable materials. This liquid in particular is polyethylene oxide, or polyox. This gel is very thick because its chain molecules like to stick together, a process called cohesion, giving it an elastic quality, acting like beads that are attached to a chain. This allows it to self-siphon, pouring itself without emptying. But it's more than just a party trick. A study in 2023 uncovered polyox's potential for 4D printing. This is a 3D printed form able to morph into different shapes and then change back when it changes temperature or is exposed to electricity. Since polyox has good shape memory, it could enhance the printing ink's viscosity and allow it to remember which shapes it already has made. Man, is there anything this polymer can't do? Magic fabric. How infuriating is it when you spill your drink on your freshly cleaned t-shirt? Oh, not again. Well, here I have a complete game changer. This is a type of fabric that's hydrophobic, meaning it repels liquid. What? Yep, liquids simply roll off the surface, keeping you and your clothes dry. This is because the fabric is treated with hydrophobic nanotechnology, a protective coating of incredibly tiny threads called filaments, which traps pockets of air in the fabric and shields it from liquids. Plus, recent advances in hydrophobic fabrics could even keep you from getting ill. These super fabrics can fend off diseases like E. coli up to 97% of the time. When negatively charged bacteria interacts with chains of positively charged hydrophobic molecules, the molecules repel them, causing disruption and then death to the bacterial structure. Pretty neat, huh? But the best t-shirt feature of all? It doesn't lock in any of that nasty sweat smell. Please, take my money. Safe in space. Spacemen and knights in shining armor. What do they have in common? Well, they both have cool outfits, they bravely venture where no one else dares, and they're always on a quest to some part of the world, or universe. Well, in 2017, NASA unveiled this ultimate mashup, a 3D printed chainmail made for astronauts. It possesses tough tensile strength, good reflectivity, heat management, and flexibility, enough to fold quickly into different shapes. Unlike the old-timey chainmail of yore, this futuristic version was not welded together, but 3D printed into stainless steel squares. These metallic tiles are able to reflect light on one side and absorb it on the other, making it a highly insulative material. Furthermore, the chainmail is strong enough to help in shielding spacecraft and spacemen alike from meteorites. Yeah, they might not have to worry about bloodthirsty medieval warlords, but getting blasted by space debris is arguably more terrifying. So, it's functional, practical, and, let's face it, cool as hell. Chainmail has officially upgraded from Camelot to Astronaut. Filling in the cracks. Finding a new scratch or a new dent on your car might be the most annoying thing in the world. I don't have the time to go and get that fixed again. So what if your car could just repair itself? Is it even possible? Well, when damaged, shape memory polymers are able to turn back to their original state when pressure and temperature is applied, like this. The scientific wizardry behind it all lies with cross-linked molecules. These hang from polymer chains and at high temperatures remain disconnected. But at lower temperatures, they link up to the chains. so a tear can be healed at room temperature simply because the cross-linked molecules can bond to the chains again. Now, self-healing materials aren't actually a new phenomenon. Self-healing concrete was actually used way back in the Roman era, but it was only in 2023 that scientists finally discovered how they made it. Ancient builders used a highly reactive compound called quicklime, which led to deposits called limeclasts forming within the concrete. When mixed with water, the deposits would dissolve and recrystallize, healing the cracks. So, whenever it rained, the concrete would heal over. This modern discovery could be used to fill road potholes more efficiently, and cars could be applied with sprayable surface coatings able to heal scratches and prevent rust. Even tires could heal themselves of cracks with these polymers. Oh man, my mechanic is gonna love this. Pollution solution. Ice cream is the greatest food in the world, in my humble opinion, but in the near future, your favorite foods could eventually contain one very unexpected ingredient: plastic. Yeah, you heard me right, plastic. The first ever food made from plastic waste was created by student Eleonora Ortolani in 2023. She took a small amount of plastic and broke it down using an enzyme, a protein that speeds up chemical reactions placed in E. coli bacteria. This breaks the links formed between molecules in the material. Once this enzyme breaks the chain, it's actually no longer plastic, but a collection of unlinked tiny molecules called monomers. She then used another enzyme to synthesize and combine the unlinked monomers to form the chemical structure of vanillin, which is a larger molecule that creates the flavor in vanilla. Then, this was successfully used to create flavored ice cream. Ortolani believes that a similar process could be used to turn plastic waste into more than just ice cream flavorings, but proteins and carbohydrates too. Imagine, one day you're drinking from your plastic water bottle, the next, that bottle is being used to make a sandwich. Wow, there's so much new material to unpack here, and you can discover even more by hitting like on this video and subscribing to my channel. All done? Great. What's next? Computer crystals. Forget one small step for man, one giant leap for mankind. Nowadays, it's more like one small right click for man, one giant leap for AI. And some recently discovered materials are no exception. A Google AI model called GNOME has been used to discover 2.2 million types of crystals, 380,000 of which are materials that could genuinely power our future technology. Google launched GNOME in 2023, feeding it information on crystals from a wide database. When they ran the model, it was able to generate new crystal structures and predict how stable they would be in reality. 41 of them are now being tested, as the AI model gave the scientists a recipe that let them successfully grow the most promising crystals in the lab. Currently, we have no way of knowing just how powerful these crystals could be, but some scientists have claimed that they could revolutionize future tech. But how? Well, some crystals are already used in lots of pieces of tech like computer chips, electric batteries, and solar panels. This is due to a wide range of unique properties that allow them to conduct heat to keep computers cool, store energy for long periods of time, or, in some cases, generate electricity, like quartz, which can create small amounts of electricity when it's pressed or squeezed. Finding new crystals that can perform these abilities while being stable enough to work without decomposing is traditionally a long, painstaking process. But the millions of crystals rapidly found by GNOME could offer any of these properties, or more undiscovered abilities, and 380,000 of them are considered very stable, which means they can be used without decomposing. This means we may have access to newer, advanced ways of powering and increasing the speed or lifespan of electronics, all due to an AI model that's made for hunting crystals. Well, no one can say we're living in the dark ages anymore. Growing a home. Do you like mushrooms? I hate them, but I must admit, this new material has made even me a fan of fungi. Since 2018, Blast Studio has developed a new construction tool you can use to not only build with, but that you can eat. Mycelium are the roots of a fungus, like mushrooms, which are incredibly important to our ecosystem. One of its important properties is being able to decompose organic compounds. So, Blast Studio used discarded coffee cups, which are shredded and added to water to create a pulp. This is then mixed with the mycelium to form a paste and 3D printed into shape. The pieces are stacked together, and the mycelium begins to grow between each piece, fusing them together. Eventually, they produce mushrooms that can be picked from the structure and eaten. But once each piece has fully fused, the whole structure is heated to 176 degrees Fahrenheit to dry out and stop its growth by killing the living mycelium. But it's not over yet. Due to its insulating and fire-retardant properties, this dried-out version can still be used in architecture. Because it can be printed into all sorts of shapes, this material knows no bounds when it comes to construction. You want a desk, or a lampshade, or an entire building made of mushrooms? Mycelium is your guy. Your fun guy. Get it? Get the, let's move on. Invincible alloy. If you think you work well under pressure, think again. You'll never come close to this mighty material. It makes titanium look like cotton wool. In 2022, NASA created an alloy called GRX 810. Now, an alloy is a metal made up of 2 or more different elements. For example, bronze is an alloy consisting of copper and tin. Well, GRX 810 was 3D printed as an alloy combo of nickel, cobalt, and chrome, laced with tiny nanoscale particles of an oxide called yttrium. This oxide strengthened the material so much that it was able to take up to 3,000 pounds of pressure per square inch, while enduring temperatures of 2,000 degrees Fahrenheit. And let me tell you, it didn't just survive this test, it annihilated it. Other alloys in the same conditions lasted around 10 hours, but GRX 810 lasted for 9 months. NASA is now considering using it for aircraft parts, particularly to create nuclear thermal rocket engines. These thermal engines could power faster missions to Mars and far beyond, if they discover a material that can withstand the heat of its reactor. And you know what? I think they might have. Reach for the stars, GRX 810. Metro Glow. What do you love about the nighttime? For me, it's seeing the lights of a big city in the dark. But it's gotta cost a lot to keep those lights running through the night. And not just financially, but environmentally too. Enter Glowy, a company that uses bacteria to light up the night sky. Founded in 2014, this operation was inspired by bioluminescent organisms, which are able to naturally emit light in dark surroundings. It's thought as many as 90% of marine organisms possess this ability. So, Glowy extracted non-toxic bioluminescent microorganisms, like this bacterium, Alivibrio fischeri, and suspended them in saltwater tubes. Inside, the glow from the bacteria illuminates the liquid, creating a source of light that runs on less energy and water than LED lights. All the electricity used to power city lights, for example, could theoretically be swapped for this biological lighting. In 2019, a town in France, Rambouillet, tested out the lights for themselves. It seems a little dim to replace streetlights for now, but that doesn't stop this being a bright idea. Shrimplastic. You wouldn't usually associate shrimps with plates unless it was being served on your plate. Well, this is Shrilk, a degradable bioplastic made from chitosan, a sugar derived from shrimp shells, and a protein called fibroin, which comes from silk. This unlikely combo has produced a surprisingly versatile new material that can take both rigid and elastic forms. This is because Shrilk is hydrophilic, meaning that it's attracted to water molecules and will happily absorb, dissolve, and mix with them. This means Shrilk can become a hard plastic used for things like cups and plates when it's introduced to a little water, or an elastic plastic like saran wrap when it's exposed to lots of water. Shrilk isn't just a swapsy for manufactured plastics, though. Shrilk can grow plants from its own bioplastic soil. It decomposes within just a few weeks, leaving compostable remains that release nutrients which support plant growth. As for clothing, well, synthetic fabrics and plastics are everywhere. In your jeans, your coat, your favorite t-shirt. Shrilk could substitute the synthetic for the sustainable. Yep, a dress made from shrimp might just find its way to the shop floor. Just wait, I'm gonna be wearing the finest Shrilk money can buy. Better batteries. Don't you hate it when you realize your phone's battery life is getting shorter and shorter in front of your eyes? Well, what if there was a new kind of battery that could last not hundreds, but thousands of charge cycles? In 2024, a new substance was discovered by an AI model. By narrowing 32 million possibilities down to 18 in less than a week, N2116 successfully made the cut. A material that could replace lithium-ion batteries, the same kind your phone uses, and reduce their use up to 70%. Lithium batteries are made with lithium extracted from brine deposits, reservoirs filled with very, very salty water. But the resource is starting to run out, with demand estimated to increase tenfold by 2030. Furthermore, these lithium batteries use liquid electrolytes to conduct the electricity, which are highly flammable and explosive. N2116, in comparison, has a solid-state electrolyte, meaning that all of its parts are made from solid materials. This makes N2116 much safer to use, and even more impressively, solid-state batteries can also store more energy inside them than batteries with liquid electrolyte, which means they can last longer and charge faster. Now, the lifespan of a lithium battery is roughly 2 to 3 years, or 300 to 500 charge cycles. With the thousands of cycles N2116 possesses, you could be looking at over a decade of regular use. Cities with battery-operated lights, traffic signals, cars, even power grids, N2116 could change it all. May need a catchier name, though. Shell of gel. You wouldn't think air, the stuff we breathe, could be a building material, would ya? Well, this is the insulation material you've probably never heard of, aerogel. Yeah, it sounds like a Walmart shampoo brand, but it's actually the world's lightest solid material, with 99.8% of it made up of air. The other 0.2%, a gel made from a polymer and a liquid solvent. The result, an incredibly porous, fire-retardant material. It's also been used in space to capture projectiles like space debris and micrometeorites. However, impact can cause irreparable damage to the gel. It's been used since its discovery in the 1930s, but scientists have now created a newer, tougher material to replace it, TSAM, or Talon Shock Absorbing Materials. In 2022, a protein called Talon was formed into a hydrogel, material composed of a solid polymer and water. Talon's shock-absorbing quality means that it's capable of absorbing the impact and speed of projectiles without the force of the blow affecting it. In fact, hydrogel was able to capture small projectiles at speeds of over 3,350 miles per hour. That's over 4 times faster than the speed of sound. And how's this for innovation? It may even protect us from the Martian atmosphere. That's right. Hydrogel could be our best building block for future homes on the red planet. Got your spacesuit ready? All you can eat. Are you tired of throwing out all the containers from huge takeout orders, or constantly throwing out food packaging? Well, get a load of this. This is Notpla, a company that makes food packaging entirely from biodegradable materials. This means that they can be composted to feed worms, microbes, and fungi, unlike normal packaging. Did you know that it can take hundreds of years for plastics like these petrol-coated containers to decompose? Well, since 2017, Notpla has replaced over 3.5 million units of plastic food containers with their seaweed-based bioplastics. Researchers from the University of Nottingham have taken this idea a step further, creating packaging made from konjac flour, starch, cellulose, and proteins. This means that after tucking into your favorite takeout, you can eat the container too. That's not the only edible plastic around here, though. Notpla also created Uho, an edible water bottle, again made from seaweed. Packaging water in these little balls can take off 450 years of decomposition time, compared to just 2 weeks for Notpla's materials. Not to mention, it fulfills a forbidden Tide Pod temptation with its squishy texture and bright colors. Could you imagine Uho branching out into sodas? 'Cause I need a Coca-Cola bubble in my mouth right now. Melting metal. If I spot something shiny, I can't help but be intrigued. And gallium is the perfect example of something that's caught my eye. It's a soft, silvery metal which can come in both solid and liquid forms. When liquefied, it sticks to most surfaces, including skin and glass, leaving a residue if you hold it. This material is commonly used to conduct electricity in technologies like Blu-ray and solar panels. But in 2023, researchers created a robot made from gallium with magnetic particles inside. These particles allow scientists to control the robot and also creates a magnetic field which generates electricity. When this happens, the gallium becomes hot and starts to melt. You see, gallium has a low melting point of 85 degrees Fahrenheit, which is very close to room temperature at 68 to 77 degrees Fahrenheit. This makes the transition from solid to liquid very easy to induce. The robot was able to pass through metal bars by liquefying, then reformed into a solid using a mold on the other side. Yep, scientists are basically recreating a mini T-1000 from Terminator Judgment Day. If you've watched the movie, you're probably hoping this technology won't go that far. Super spray. To say I'm clumsy is an underestimate. Oh, there goes my mic again. Oh man, my phone too. What the No, my eggs! My many eggs! Ugh. Is there a way to stop me from breaking everything I set my hands on? Actually, yes. Polyurea is a waterproof material that protects objects from the 4 horsemen of destruction: corrosion, rot, rust, and breakage. Yep, this unlikely hero can defend your possessions from a blast impact of over 1,000 pounds of pressure per square inch. It's a sprayable elastomer, adhesive to materials such as metal, cement, even food. This spray is formed by a synthetic resin and isocyanates, which are chemicals found in paint and varnishes. Through polymerization, these substances create a flexible but incredibly tough elastic material, able to take stresses from 1,000 to over 6,000 psi. I never thought I could see one of my precious eggs crushed under a car and survive. Despite elastomer coatings first originating in the 1980s, this material has been clocked as a great feature of structural designs, reinforcing buildings from weather and damage. Forget buildings, though. I can finally fully protect my many eggs. Powerful putty. No one could resist playing with silly putty as a kid, or as an adult in my case. So many varieties and colors to choose from. But wait, this isn't just silly putty. This is a magnetic putty. Putty is an elastic polymer made from silicone oil and boric acid. It was first invented as a children's toy in the 1940s, but the magnetic type has become a growing phenomenon over the years. So what makes it magnetic? Well, it includes iron oxide particles, which attract magnetic force. When a magnet is nearby, the putty is not only drawn to it, but it can also consume the magnet entirely. And it's not just made for fun. This putty has been used to enhance robots. Studies from 2023 show that magnetic putty is a robot's best friend. providing extra magnetic force and load-bearing support. It's also able to navigate through small areas too, as narrow as 1.5 millimeters. This means it could be used to travel inside the body, helping doctors find and retrieve swallowed objects. Yep, it's no longer just a toy, it's a technology. Stronger than steel. I love an underdog. The guy that's always in the background but has the most to offer, like our next material, carbon fiber. Best believe it's the stuff that's doing all the heavy lifting behind the scenes. A material twice as stiff as steel and up to 5 times stronger. It's able to take stresses between 3,000 to 7,000 megapascals. In comparison, your standard steel reaches 550 megapascals. But how? Well, carbon fiber is composed of, as the name suggests, carbon, the same stuff diamonds are made from. Carbon atoms can bond together to form long crystalline strands that create incredibly tight chains. This results in a material that is chemical resistant and can take temperatures of over 3,600 degrees Fahrenheit. Because it's so tough but also lightweight, it can be used in everything from construction to medical implants, like bone plates and prosthesis. Now, you're probably wondering, if this material is so strong and helpful, why aren't we seeing it everywhere? The answer, unsurprisingly, is money. It's more expensive to produce than other materials, so plastic and metal are still used to keep costs of everyday items down. But one day, my dream of owning a carbon fiber toilet will be realized. Bright smiles. Now, the discovery of this next material is enlightening. Literally. In 2020, scientists created a material called small molecule ionic isolation lattices, SMILES for short. These are the brightest fluorescent materials on Earth. This new material is made from small fluorescent molecules in colored dyes, which are packed together tightly. The problem is these molecules are so close together that they can only emit a dim glow when they enter a solid state. So, scientists threw cyanostar into the mix, which is able to force the molecules apart, allowing their glow to escape and shine brightly even within a solid structure. This allows the liquid solution to be turned into solid shapes, by first being grown into crystals, then turned into a powder, and finally spun into a film. Then this substance is used to 3D print these shining shapes. SMILES have a bright future, as they lend themselves well to powering 3D displays, solar lasers, and even medical imaging, like X-rays. Personally, I'd make the biggest, brightest Christmas tree ever. Blocking the bleed. There's always a moment of panic whenever you find some blood on yourself. Wait, am I bleeding? Where's it coming from? Where's the first aid kit gone? Well, there'll be no need to go scrambling for Band-Aids in the future, because VETAGEL has created a material that completely stops bleeding in under 20 seconds. This gel is a polymer able to form a barrier when exposed to blood or tissue, like a bath plug that stops water from flowing. It collects fibrin, a protein that produces the clotting of blood, which prevents additional bleeding. When it does this, the bleeding will stop completely under the gel's protective mesh, and as it's composed of natural polymers made from algae, the gel can be left in the wound and easily absorbed by the body. No more ripping off Band-Aids. Since 2021, VETAGEL has been used on animals in veterinaries from America to Asia. But it might show up on the human market real soon. In fact, the U.S. Department of Defense is interested in the gel, which could help wounded soldiers on the battlefield. Able to be used for both skin wounds and organ injuries, we might have an amazing new medical device on our hands. Literally. Manufacturing marvel. In my spare time, I love 3D printing my favorite Pokemon into real-life models. In fact, producing game-accurate Jigglypuffs is all that I use it for. Don't judge me. But this process isn't just for making toys. It can actually improve the way we manufacture everyday items. Carbon Digital Light Synthesis, or CDLS, is a new 3D printing process developed by the digital manufacturing company Carbon, which creates extra strong parts faster and more accurately than other printing methods while leaving zero waste. This is how it works. A liquid plastic resin is cured into shape by UV light as it prints. Once the part is printed, it's baked in an oven, where heat will strengthen the materials, enough to take the pressures of up to 3,000 megapascals. That's over 435,000 pounds per square inch. Because this carbon process can produce all kinds of materials, CDLS printing could become the next big thing in mass market production. CDLS could give us our industrial fabrics, rubber products, and vehicle parts in half the time it would take to test just one design with another manufacturing method. Aside from all that, I wonder if it could make a super tall, super tough Jigglypuff for me. Like I said, don't judge me. Which of these newly discovered materials do you think is the most innovative? Let me know down in the comments below, and thanks for watching.